Okay, we're gonna finish up our vector examples here. We have three more to do. Um, the first one is finding a unit vector that has the same direction as a given vector. And to do that, we're gonna take the original vector and divide by the magnitude. And so we're gonna look at this first one, find a unit vector in the same direction as v equals 5i minus 12j, and then verify that it has a magnitude of 1. So what we're gonna do is we're gonna start by finding the magnitude of the given vector by doing the square root of 5 squared, apologize, that looks like 6, plus negative 12 squared, so we get 25 plus 144, is that our square root? So the square root of 169 gives us a magnitude of 13. So all we really have to do then is take our original vector and divide by the magnitude of that vector. So we're going to take 5i divided by 13. Actually, I'll set it up this way. 5i minus 12j divided by 13, and then we typically split that into two components so that it looks like that. Okay, so this would be your unit vector. And then to make sure it's actually a unit vector, we're just going to verify that the magnitude of that vector is actually 1. So we're going to go ahead and do the square root of the quantity of 513 squared plus negative 1213 squared. So we get 25 over 169 plus 144 over 169. Is that our square root? So if I add those, I get 169 over 169, which is 1. The square root of 1 is 1. Okay, so our unit vector is that vector that has a magnitude of 1. The next piece is going to help us with some application problems, or just creating a vector based on what we're given. So writing a vector in terms of its magnitude and direction, if we have an angle measured from the positive x-axis to v, then we could figure out the rectangular form of the vector using the magnitude times cosine of the angle times I plus the magnitude of sine of the angle times j. So remember, I is your horizontal direction and j is vertical. So cosine is your representation of your x, sine is y in trig, and that's what we're using that way. So what we're going to do is the wind is blowing at 20 miles per hour in the direction of north 30 degrees west. Okay, so when you're thinking of this, okay, due north is up here, right? From there, 30 degrees west would be right there. Okay, so this is 30 degrees. So our actual angle is going to be this whole thing. So we're going to do 90 plus 30 to get a theta of 120. 20 miles per hour is going to be your magnitude. So when I plug this in to find my vector, I'm going to do the magnitude times cosine of 120 degrees times I plus the magnitude times sine of 120 degrees times j. And this is actually on my unit circle. This is the same as 2 pi over 3. So my cosine at 120 is negative 1/2 because we went to the left. So 20 times negative 1/2 times I. And my sine is going to be the square root of 3 over 2, positive because it's going up. And we're going to simplify. So our vector is negative 10i plus 10 square root of 3j. Okay, last example is more complicated. It's giving you two forces, F1 and F2, of magnitude 10 and 30 pounds, respectively, act on an object. Okay, so we have two different people pushing a box or something like that. The direction of force 1 is north 20 east. Okay, so that's actually going to be, I'm going to do this in another color, about here, and its magnitude is 10, so I'm going to make it shorter. So we're going to call this, awful drawing. We're going to call this F1. So this is 20 in here. And then F2 is acting on the object in the direction north 65 east with a magnitude of 30. So this is 65 degrees. This is 20 degrees. So we're going to use that. Okay, so for F1, our magnitude is 10, and the angle we're going to use is not 20, it's actually 70 because we need to go from our x-axis up to the angle. So we're going to do cosine of 70 degrees times I and 10 sine of 70 degrees times j. You're going to type this in your calculator. Please make sure it is in degree mode, not radian mode. So 10 cosine of 70 is going to give you about 3.42 times I. And then 10 times sine of 70 is going to give you about 9.40 j. Okay, so this is the vector for our first force acting upon the object. For F2, we're going to do the same thing, but our magnitude and our angle are a little different. So our magnitude is 30 for this one. And then again, we're going from our x-axis to the angle, so it's not 65 degrees. We're going to do 90 minus 65, which gives us 25. So 30 times cosine of 25 degrees I, and 30 sine of 25 degrees j. Type that in your calculator. So F2 is 27.19 I plus 12.68 j, and those are our two forces. Now, to figure out how those are impacting the object, we need to add them together because both forces are acting on that object. So we're going to call this force equals F1 plus F2. So if I combine those two together, 3.42 plus 27.19 gives me 30.61 I. And 9.40 plus 12.68 gives me 22.08 j. Okay, so this is our rectangular form. If we want to find the force in the direction, we need to find the magnitude. We need to find the angle. So let's find our magnitude first. So we're going to do the magnitude of F is equal to the square root of 30.61 squared plus 22.08 squared. Type all that in your calculator, take the square root, you get about 37.74, and that's going to be your force. And we could label that pounds as well. And then to actually find the angle, we're going to use the fact that cosine of theta equals cosine of theta equals the A, which is 30.61, divided by the force, or the magnitude, 37.74. So we get cosine of theta equals about I lost my calculator. And then you're going to do inverse cosine. Okay, so 30.61 divided by 37.74 is about 0.81. And then do inverse cosine, so the second cosine of 0.81, and you find that theta is about 35.8 degrees. So that is the direction. So when you think of this, this is 25, so this is my F if I were to graph it. Okay. So we really want you to be comfortable with, or I shouldn't even say comfortable, familiar with for BC Calc. And when you continue on, there is a bunch of practice in this packet. So there's a checkpoint that matches, there's some vector practice, there's lots of vector practice, and then there's some more application problems that you can try. I will throw in some parametric equation materials here in a couple days. Have a great day. Let us know if you have any questions.